This video is going to take you through Chapter 10, Programming and Logic. There's some review of object-oriented programming. We'll try to make it go a little bit quicker maybe than the last one. This one's going to look specifically at designing classes, and you should be familiar with those from Greenfoot, so we're going to just review some of that, although we will do and show a business example in here before we are done. Object-oriented programming is OOP, and that's what you have been using all year long, especially with our Greenfoot environment where you can actually see the physical objects. You know, way back when we started with the wombats, and then you moved to the crabs and the lobsters, etc. And often when you are using object-oriented programming, you are still using ideas that are in procedural programming, that you are using variables, methods, arguments, and you're using all the different structures that you would in procedural programming. But object-oriented programming literally involves thinking of everything as an object. And you guys have gotten a pretty good start with that in your Greenfoot, because everything over here that you've worked with, your world is an object, your actor's an object, your plotter, whatever you're working with, they are all objects that you guys work with. So remember that when you're working with object-oriented languages, you are developing classes, and you don't actually create objects until you place things on the screen. So for example, over here, if I wanted to create a new rabbit, I could do new rabbit and place it on the screen. So the class gives you the outline for that particular object. If we take a look at rabbit, we can see that a rabbit is defined according to these specifications. This is the class, this is the outline for the rabbit, but you don't actually get to creating an object until you put, or in our case, you create a new object and place it on the screen. We talked about polymorphism in the last slide. We'll talk a little bit more about it here. There's also inheritance and encapsulation. Inheritance you already are familiar with, where the superclass inherits everything from the subclass. So back on that screen, sorry about that, we're jumping around too much. But back on this screen, the actor is the superclass and these others are subclasses. And everything that's in a subclass will inherit all the attributes from the superclass. This you should be familiar with. In a single instance of a class is called an object. So a single crab, piano, leaf, or a circle if you were creating circles. Attributes are those characteristics that define that object. They're the data components that belong, and every single time you create a new object of that type, they're going to be set. These are called the instance fields, or they're called the instance variables. In an automobile, for example, we might use make, model, year, and the purchase price as its attributes. I don't know if I would include purchase price in there, but make, model, and year for sure. A planet's attributes would be color, mass, and gravity. If we go back and glance at our Greenfoot, the rabbit, here are the attributes. A rabbit has a maximum age, a breeding age, breeding probability, and a litter size. And so those are the attributes set up. Those are the instance fields for that particular. Actually, those are all constants. So if I scroll down, I don't know if it actually uses any instance fields. Let's take a look at the other classes in here, just to glance at something. If I look at the plotter class, and we see if they have any instance fields. In the plotter class, this one's a little bit better. These are all instance fields. So this one's a little bit different because it actually uses what we call a J-frame, which is a panel. And so, but those are all things that are needed in order to draw that window that's interactive the way it is. So methods, you've been writing those and using those all semester. So classes have attributes and classes have methods, and the methods are the actions for carrying out things. So you could have a dog class, and the attributes could be the name, the age, and whether the dog is vaccinated, and you could have methods to change the dog's name, or change the dog's age, we could also do, or update the vaccination. In your planet class, you could have the name of the class is body. Its attributes were gravity, color, mass, and then you had methods. And the first one is a constructor. Bounce at edge, apply forces, apply gravity, etc. So you want to remember that is a relationship. And so anytime you have this diagram here, a plotter is a actor, an animal is a actor, a rabbit is an animal, a field is a world. When you have that is a relationship, you have inheritance. All objects are created or instantiated. They have a state, and that state of the object is held in those instance variables. And that's why when you guys can check to see, if you remember back when you worked with the cat, whether the cat was hungry or not, or the cat was tired or sleepy, that was basically a state variable. Polymorphism is the idea of reusability. And so this is another example. It just talks about the word open. So opening something could be opening a drawer, opening a file, opening your eyes. And so it has a different application or a different use depending on the object. So if the word open is used in a bank account, it's going to open an account and set a balance. If it's the word is open and it's used with a dungeon, the compiler is going to know to open cells and close cells, allowing prisoners or pardoning prisoners, etc. And if it's a saved game, the compiler knows to open the game where you left off. And so there's a whole bunch of different varieties of how open could be interpreted, and so it has many forms. Inheritance, you guys have the basic idea of inheritance down. UML diagrams we talked in our other video. Encapsulation goes along with that idea of trying to hide the data and basically not letting you see any of the behind the scenes work. You want to have you want to protect that data if possible. And so you guys have worked with some black box programs. The random number generator is an example. You don't know how it works, but it does work, and you don't care how it works as long as it works. And so that's called a black box method, and that falls under this idea of encapsulation. So it's the process of combining all the attributes and methods in a single package, and then you don't have to let people know all the details. That's how businesses keep some of their secrets. They just encapsulate everything into a black box program or a black box method, and so you don't actually ever know how it works, so you can't steal their ideas. When you define a class, it always has three parts: the name, the attributes, and the methods. And we're going to talk about class diagrams here in a few minutes, and you're going to see those crop up, and I believe we're going to talk about a business example coming up. There are some examples. Remember, when you declare a class, you don't actually create an instance of an object yet. Oftentimes you will have getter methods, and they are called accessor methods. You haven't dealt with them a lot in Greenfoot, but sometimes you want to get, you have actually with the get X and get Y, and that one happens to be in the rabbit. I saw that on a few of the screens where you're going to be getting the X and getting the Y. Those they return the values for those instance fields, and they are called getter methods. So any attribute that a class has, we often use or write a getter method. A setting method is one that you have not really used in Greenfoot, and that's where you can set the attributes. You can change the color, you can change the size, etc. When you use a setter, you do have to have arguments here, because if you don't send in a new value, you're not going to know what to change the values to. Okay, it's pretty much an industry standard that you use the word set before that, but you don't have to. Worker methods sometimes are also called mutator methods. Basically, they're the methods that do everything else. Applying gravity. Okay, it's neither a setter nor a getter. It does a job. A mutator method is a special type of worker method, and it's a special type of worker method where it changes the instance field. When you define a class, you are the person that's defining them, so they are called user-defined types. And so you could probably, they say more accurately, call that a programmer-defined type. Object-oriented programmers call them abstract data types. So you might see this ADT, that's abstract data types. Simple numbers and characters are called primitive data types. So you guys have been working with both abstract data types and primitive data types in Greenfoot. Your integer, Boolean, doubles, those are your primitives, strings, and your abstract data types are all the actors on the right-hand side of the field. And when I say right-hand side of the field, I mean over here. So these are your abstract data types. These are your object-oriented types, your ADTs, because a user, somebody defined that somewhere. Somebody created what a plotter was, and they wrote the definition for that. And so it's an abstract data type. Now, the last few slides here are going to talk you through something called creating class diagrams. And initially, I was going to have you guys do these for your semester projects, but we didn't get there. But you will use these in the advanced class, those of you that are taking C++ next semester. And so you should know just a little bit about them. But the first part of a class diagram is the name. It comes in 3 sections. The middle part are the instance fields, and the last part deals with your actions or your methods. And so the following is going to give you an example of using a business example, and it's going to talk you through the idea of the setters, the getters, the worker methods, and it's also going to show a class diagram for that. So this is a class, not like what you're used to seeing because it's not in the Greenfoot environment, but we have the name of a class, which is employee. We have the instance fields, which are last name, hourly wage, and weekly pay. We have a constructor, and we have setter methods that set the last name, the hourly wage, and we have getter methods that return the values for the instance fields. Usually there is a getter method for every single one of your instance fields. And then we have a mutator method down here that changes the value of the weekly pay. So this is an example of a class that would be used in business. And if you're going to take C++ next semester, you will be writing some programs or classes like these. The class diagram that goes with it looks like this. Name of the class, first part of the first section. All your instance fields are listed next, and then there's usually a colon, and then the data type follows it. And then you have a list of all your methods. The constructor is usually the first method, and then you can list all your setters and getters, and then any worker or mutator methods that you have. Notice that the return type works 2 things. The data type for the parameter is listed, and then the return type. You don't actually have to have all the parameters listed. They really are more importantly involved with now that's not what I wanted to say. It's more important that you know the data type than the actual name of the method passed in. So the class diagram is a template, and basically this provides your method signature for you. When you create the class diagram, you just saw an example of it. You also want to refer to what we call public versus private access. When you guys have been working in Greenfoot, most of your methods that you guys have used have been publicly accessible, public. You have used private instance fields. They talked about that in the Greenfoot book. And when you're using those in a class diagram, we designate those with a minus for private and a plus for public. And so just know that if you were going to create a class diagram professionally, you would want to use this format. The other 2 slides that we talked through we're just mentioning private versus public. This particular example here does have a private method that's used in the class if we go back and look at that. And the reason for that is the only time that calculate weekly pay is called is in the constructor. We don't want anybody from outside this class using it, so we give it private access so I can use it within the class, but nobody else from outside the class can access it. And so that's a way of also protecting your data. And then there's a summary slide. And you have access to these slides available on course sites. That should give you, if you listen and go through, just listen through these couple of videos here, that should give you enough background for your final exam. We might talk a little bit in class about the notes packet I'll make a few brief comments on that, but most everything that I've mentioned is just reviewed in this note packets. We did not actually do this note packet in class this year, but it will be a reference and I'll talk about that in class. That is it.